So I'm Harsh. I'm a software developer. I'm doing backend and front end and working on system design. So today we are doing an experiment. So I want to analyze how much does the cache improve the performance of my app. So the plan is simple. I have a simple Flask app which is which is connected to my SQL. Let's make a connection. So this is my first app, and I have another app where I have a Flask app. Then I have MySQL, and I have a Redis cache. Redis. So Flask is connected to SQL, and SQL is connected to Redis, and we can see that the Redis is also directly connected to the Flask app. Okay, so both the app have similar codes, similar endpoints. The only difference is that we have Redis on this. So what I want to do is I want to run both the apps, app 1 and app 2 parallelly. So let's do that. Before that, let's go towards my app and see the endpoints. So this is my first endpoint, that is categories. It returns all the data that is in categories. We have another endpoint called products. It returns products. It is also enabled with pagination. We have another endpoint that returns the specific product by the primary key. So this is the cached app. So if there is a data in the cache, we return the data. Otherwise, we return from the database. That is MySQL in this case. So this is another endpoint. The first one, this returns the product, all the product from a specific category. Again, this is also the cached endpoint. This is another endpoint which returns the price of the particular product. So what it does is it calculate taxes, region, membership tier, quantity that we want to order, and then calculate the price. So this is the most CPU extensive task. It needs a calculation. So this is the most slow endpoint. So I have done this just to calculate how much, in this case, the cache improves the latency. The cache key, let's look at the cache key. So in cache key, we have the product ID, quantity, membership tier, tax, and region. So if the data is from cache, it returns directly from cache, and if it is not, it first fetches from the database and then save it to the Redis. And next time, we can directly serve from the cache, improving the latency and the CPU uses. So there is another app which is without cache. This has all the similar endpoint. The only change is it does not uses the Redis cache. Let's have a look at the Docker Compose. It has two databases, one for SQL without cache and other for MySQL with cache, and also have a Redis. So this is without cache. This runs at the endpoint 5001. Run the app which is with cache. The without cache one is already running here in this terminal, and here we'll be running the app with cache. So the with cache app is running at 5002. Now comes how will we test the performance? So let's go to the whiteboard. We have a thing called Locust. Locust. So what Locust does is it is a load testing application where we can load test the endpoints. So I will be running two Locust, one for each of the app. What Locust does is how I have configured it. Let's go to the Locust code. So here we have the two Locust file. First, let's look at the configuration file. So we will be ramping up to 1200 user hitting the endpoint at the same time, but it will not be instantaneously. It will ramp up slowly. So the runtime will be 20 minutes. There are two app. This is for the port 5001. This will test the app which is without the cache. So here I have defined all the endpoints that we need to test. Here is the product endpoint, product with the pagination, product with a specific ID, and all the products for a category. And this is for the price endpoint. So what it does is it calculates the price of a product ID based on membership, taxes, and reason. So here we are calculating the price of the product. Here we are calculating the price of product for a specific quantity. Here we're calculating the product price with a specific membership and quantity. Here we are doing for a reason, quantity, and for a specific product. So the code for both are same. The endpoints are same. The number of users are same. Time limitation is same. So let me start the locust testing. How we run is we use the locust and then define the file and then define the host to which we need to direct the traffic. So I will start running it, and on our second terminal will be running for the cached one, which is the localhost 5002. So in this terminal we are testing the endpoint for without cached app, and in this terminal we are testing the with cached app, that is localhost 5002. So the so it will host a web app kind of thing. The port for first is 8089, which is default. For the second, I have defined the port to be 8090. So 8090 is without 8090 is with cache, and 8089 is without cache. So let's go to the our testing file. So this is 8089. Here this is the locust interface. So we can see that there are 1200 user, which will ramp up like user started per second is 1.33. So per second, 1.33 users will be added to the test. So this is port 8089. This is for without cached app, and this is for with cached app. So let's start the test. Let's see. So here we can go to charts, charts, charts. So in charts we get three outputs. The first is response per second. The second is response time, which is latency in how much millisecond we are getting the response, and this is the number of user. The number of user will be ramping up rapidly. So I am assuming since we are using Redis cache, the response time for this chat will be low. We are ramping up user. Now I'm assuming that for the first time it is serving from directly from database until and unless there are some keys which is already stored in our cached database. So let's wait for some time. Meanwhile, let's see what are the times. So for without cache, we have the 50th percentile at 5 and 95th percentile at 17. Here we have 3 and 8. Okay, so it is already low, but let's see, wait for 20 minutes and see how the result goes. Similarly, there is another tab called stats where we can see how many endpoints we are hitting and what all endpoints are we hitting. So we can see that we are hitting the categories endpoint. We have done 29 requests, 0 has failed, and this is the median latency time, which is 4 milliseconds. And let's see at the, yeah. So here the median time is 3, here it is 5. So I'm assuming the price for the price endpoint will have a major difference in the timing as well as the response timing, response per second. So this is the price endpoint. It is 3 millisecond at median. It's 2 millisecond at the medium. Not a major difference till now, but I'm assuming the cache is cold starting. So let's wait for some time and observe the chart. So you can see the user is ramping up. We have 213 user and then it will ramp up every second. Now it is 218. It will go till 1200 user hitting the endpoint at the same time. So let's see. The another thing which you need to notice is the graph scale. So this is from 0, 10, 20, 30 and 50, but the graph scale here is too low from 0 to 50. So here we have the stats. Let's first see all the metrics that the Locust sources. So the first one is number of requests. The second is number of the request that has failed. This is the median millisecond, which means that the number of 50% of request was served within this time. This is 95%. This means that 95% of request was served within this time. Similarly, 99% average the minimum response time and the maximum response time. So let's see at the result. This is the total aggregated. So this one is without cache. So without cache was only able to serve 490k request. With cache was able to serve 531,000 requests. The number of fail was larger in without cache app, which is around 210k. For with cache, this was around 156k. The median response time was 65, and here it was only 15. So here we have all the different kind of metrics. So now let me put this into a Excel table for clear understanding. So let's see, the number of request was 531, and in this case it was 490. So we can say that for with cached app, the number of requests exceeded by 41,000. The failure were low in with cache app by 53,000. The median time was less by 50 millisecond. The 95 percentile was low by 400. The 99 percentile was less by 800. The average response time was less by 132. The minimum response time was equal, and the maximum response time for some reason was more in with cached app. Yeah, so that's it. This is how you can use cache to improve the latency of your app. See you until the next video comes out. Please subscribe us for more such video. Thank you. Good.